So welcome back, everyone. In the
Sir, good evening.
good
Sir, good
evening,
evening, sir.
good evening, brothers. In yesterday's session, we started with a basic discussion of measurement system analysis. We started with a thought that there is measurement error everywhere. We must start with an assumption that, unless proven otherwise, every piece of data may be incorrect, and data, which is a very important part of our decision making. If that data itself is wrong, the subsequent decisions that will be made will also be incorrect. That is where all of this started. One example that we used yesterday was of the file transfer. We said that a server has noted that a file transfer took 14.157385 etc seconds, while you as a data collection person have noted that it took 14 seconds. While in the Puritan sense, you are incorrect, but you still have to decide, does the difference matter? अगर हमने 14 बोला है instead of 14.15, will it make that kind of difference to be able to call it an error? Every day, right from we buy petrol in our day-to-day lives, are we sure that whenever each time that we are buying petrol, are we sure that we are getting the right quantity? Every measurement system, you are buying things in a grocery store, there is a measurement system involved in the grocery store. Are you sure that you're getting the right quantity of things that you are paying for? And like I'm saying again and again, data, which is the primary source of our decision making, if that data is incorrect, the subsequent decisions that we are making based out of that data would also be very likely be incorrect. So the entire exercise for measurement system analysis is to ensure that the quality of the measurement system being deployed needs to be verified so that the measurement that we have observed is as close as possible to the actual measurement. आप जिस measurement को actual measurement बोल रहे हो, let's say there was a particular product that you purchased and you said you have purchased 20 kilogram of rice. That is the observed quantity, while the true quantity may be a little less or a little more. Very likely that it will be less, because some amount of measurement error has been added to the system. The entire exercise of measurement system analysis is to look at whether each time that you are looking at the measurement system, you will have to ensure that the measurement system brings in as little error as possible. And I am of the view that measurement error must be assessed right at the borders of upper specification limit and the lower specification limit. Like in the example we were discussing yesterday, if your measurement system is such that it adds 1 gram to your measurement or it reduces it by 1 gram, right at the center, even if the measurement system were a little incorrect, it will still give you the kind of it will still create past products. However, at the border, the likelihood of a past product being referred to as a failed product or vice versa could be incorrect. So measurement system analysis करने समय you may want to assess आपके process का tolerance क्या है, मतलब USL minus LSL, और अपने बॉर्डर्स के पास जो डेटा आपके अपर स्पेसिफिकेशन लेवल से नज़दीक है, लोअर स्पेसिफिकेशन लेवल से नज़दीक है, यू मे वांट टू वेरीफाई दैट डेटा फर्स्ट, बिकॉज बहुत लाइकली है दैट डेटा राइट एट द बॉर्डर, लेट्स से in an example at AIG, we see that there are certain questions which even when you answer it correctly, it still says wrong answer. Let's say we have identified that there are 4 such questions. So एक student जिसको 92 आया, it is possible that he actually got 96, but because of that fault, he ended up getting a 92. This will have a huge impact, especially for people who are very close to the border. 60 being AIG's pass mark, someone who has received a 59%, someone who has received a 58%, someone who has received a 57% actually could have been 61. So border pe dekhna will be a more sensible thing to do each time that you're doing measurement system analysis. We are together so far?
Yes, sir.
Yes,
Actually,
sir.
I have one
Yep.
question which I put it in the chat as well.
I have
Uh,
because I'm sharing the screen, I can't
okay,
see
I'll
your chat.
just read. I mean, if in the process we do not have a specification limit,
Example,
like
a
I mean,
normal measurement.
like in our process, we do not have any specification limit which is given by the let's say by the customer.
और इन डे टू डे मेजरमेंट ऑल्सो, आप जब आलू खरीदने गए थे, आप जब सब्जी खरीदने गए थे, व्हेन यू वेंट आउट टू बाय एन ऑर्नामेंट, यू डिड नॉट हैव अ स्पेसिफिकेशन लिमिट.
Right.
इन दैट केस जो डेटा है उसी डेटा को वैलिडेट कर लो.
Okay. Okay.
नो प्रॉब्लम विद दैट.
Got it.
The idea of the measurement system is to work at reducing the measurement error that the system has observed. हमको क्या करना है? The entire measurement system analysis exercise, guys, whoever is not talking, can you get on the mute? I hear some disturbance coming from somewhere. So the idea of measurement system analysis is to identify the contributors of the error. कि measurement system में problem कहाँ से आ रही है? We identify the measurement error and we work at reducing this measurement error so that मेरा जो observed data है, observed quantity है, is as close as possible to the actual quantity. This is what we want to do from here to a here. We would want that the gauge error or the measurement error reduces. Remember that gauge and measurement are interchangeable words. जब gauge error reduce होगा तो your process is likely to become more capable. Everyone? We understand what I said right now?
Yes, sir.
And there could be different causes of variation that could contribute to the measurement error. These potential causes could be people, process, machine, scale, and environment. I have shared a fishbone with you folks yesterday. Did you guys get a chance to look at it?
Yes.
You must ensure that you read the fishbone very well, because it will give you a good understanding of what could be the contributing factors for the measurement system errors, and then one can work at reducing these errors. I would recommend that you create your own fishbone from the guidance received from that fishbone example for your own business processes. It will give you a lot of confidence. You must understand the causes of variability. That will be a huge help when you are working for improvement in your respective projects. Because I would hate to be in a situation where my measurement system is contributing to the trouble I'm in, while business process is working okay, but the way data is being collected today, the way data is being gathered, the measurement system involved has contributed to a lot of mistakes, and that is pretty much not acceptable. So you may want to work at identifying the sources of the measurement error and work at reducing them. At least at a high level, two very simple components or constituents of the measurement error will always be people and the equipment. So skill or will of the person will always have an impact on the measurement system error. आज आप सब्जी खरीदने जाते हो, the sabzi wala will be able to add a lot of measurement error, largely because he is interested in messing with that data. Wahi, if in a particular measurement system, the person involved is not capable of handling the equipment, if the person involved is not capable of understanding the operational definitions and the process involved, method की clarity अगर नहीं होगी, तो the measurement error may not yield the kind of result we want. So people, meaning skill and will of people involved, will always be a key contributor. Equipment will always be a key contributor. When you are buying petrol at a nearby gas station, the petrol dispensing machine may be compromised, and that is why there is measurement error. Maybe the machine has certain maintenance needs which have not been catered to, and that is why you have measurement error. So you should be carefully looking at the possible sources of variation for measurement system and work at reducing them. Because like I'm saying again and again, the quantity that you've received or the quantity that you consider as the true value is actually an observed value. So we would want to reduce the difference between observed and the true value. And we started to say that whenever you are looking at variation, so अगर आपने data capture किया है, let's say data for the mileage of the car, data for average handling time of a process, data for quality in a process, there is bound to be some variation. So there are two constituents of this variation. One, which is the actual process variation, and two, which is the measurement system variation. So actual process variation could be the long-term process variation, the short-term process variation, or the within sample variation. What we are interested in studying as part of our measurement system analysis is two things: variation due to the equipment, variation due to the operator. When you are looking at studying variation due to the equipment, you are essentially looking at studying accuracy, precision, stability, and linearity. And when you are looking at studying variation due to the operator, you are studying reproducibility. We are okay so far?
Yes, sir.
Yep.
Yes, sir.
So when you are doing the measurement system analysis, you guys can hear me?
Yep.
Yes,
Yep.
Okay.
Yes, sir.
So when we are looking at doing measurement system analysis for continuous data, we may want to start with repeatability. Repeatability is nothing but measuring the same thing over and over again using the same tool and by the same person. So let's say मैं अपने पुराने क्लासेस में एक एग्जांपल हमेशा देता था. My mother would sell the old newspapers at home every month. और मैं देखता था that जब कभी भी वो वेंडर आ जाए, रद्दी वाला आ जाए to buy the newspapers, she would always suspect that the data is incorrect. उसको हमेशा ऐसा लगता था that the quantity of that the person is quoting is incorrect. So to be able to be doubly sure, she would ask the same raddiwala to measure the same thing again and again. And here is what this is what repeatability is. When you get the same person using the same equipment, तो रद्दीवाला अपना एक तराजू इस्तेमाल कर रहा था. So when the raddiwala was required to measure the same thing over and over again using the same equipment, so person same है, equipment same है, और thing भी same है. This is what repeatability is. The variation that you observe between multiple data points is what is repeatability. We are together so far?
Yes, sir.
Yes, sir.
Yes.
And you may want to recall that the term variation can be very tricky. There are several ways variation can be manifested. आप स्टैंडर्ड डिविएशन निकाल सकते हो, आप वेरिएंस निकाल सकते हो, आप सम ऑफ स्क्वायर निकाल सकते हो, आप रेंज निकाल सकते हो, क्वार्टाइल्स निकाल सकते हो, एटसेट्रा एटसेट्रा. सो ज्यादातर जो पॉपुलर टूल्स हैं इंडस्ट्री में फॉर मेजरमेंट सिस्टम एनालिसिस वो स्टैंडर्ड डिविएशन, वेरिएंस और रेंज इस्तेमाल करते हैं. So Gage R&R ANOVA uses standard deviation and variance. There is a method called X bar R, वो mean और range निकालता है. Repeatability is essentially attributed to the equipment. So we were discussing in the previous session that whenever we have to check the equipment variation, we use a statistical method referred to as test retest. जहां पे प्राइमरली हम दो बहुत इंपॉर्टेंट चीजें मेजर करना चाहते हैं. वन विच इज रेफर्ड टू एज एक्यूरेसी, द अदर विच इज रेफर्ड टू एज प्रिसिशन. सो व्हेनेवर यू आर लुकिंग एट आइडेंटिफाइंग द इक्विपमेंट वेरिएशन, आप कर क्या रहे हो? अपना कोई एक प्रोडक्ट, अपना कोई एक पार्ट लिया, उसका मल्टीपल मेजरमेंट कराया, रिपीटेबिलिटी, and the same part is sent over to a standard body, a body which we are sure of giving correct results. So हमारे पास एक standard measurement आ जाए, एक reference value आ जाएगा, और हमारे पास एक data collect हो जाएगा which is about the same part. Everyone together?
Yes, sir.
Yes, sir.
So I have an Excel sheet which has, let's say, 20, 30 or 40 data points of the same part being measured again and again. And I also have the reference value. तो इस डेटा का I will calculate the mean and standard deviation. Standard deviation will be helpful for us to identify the precision of the equipment. To identify the precision of the equipment, the standard deviation that I have calculated from the data must be less than 1/10 of the tolerance of the equipment. While the accuracy of the equipment is understood using a value called bias. Bias is nothing but the reference value minus the average of the data that we've calculated. Best situation would be that you have no bias in your system. कि हमारा reference value भी, so let's say for example that I was using yesterday, I work for Pepsi and I have a bottle in which I have 100 milliliters of Pepsi stored. I send it to the reference to the standard body, and it says that the amount of Pepsi in that bottle is 100 milliliter. Now that is a standard for me. So standard is 100 milliliter, and if I have done repeatability exercises also in my company. So if I took out the mean of that data, so standard being 100 minus the mean, this is the value called bias. Bias should be as close as possible to 0. पॉजिटिव बायस का मतलब कि स्टैंडर्ड ज्यादा है और हमारा वैल्यू कम है, it means we are under measuring. What we are calling as 100 milliliter is actually more than 100 milliliter. It will be the producer's error that we were discussing yesterday. Understand everyone?
Got it, sir.
Yes. Yes, sir.
While अगर मेरा बायस नेगेटिव है, स्टैंडर्ड बॉडी से ज्यादा है मेरा एवरेज, इट मींस दैट वी आर ओवर मेजरिंग. हम जिसको 100 मिलीलीटर्स की पेप्सी बोल रहे हैं वो एक्चुअली मे बी 96 मिलीलीटर ऑफ पेप्सी है. सो दैट विल बी द कंज्यूमर एरर दैट वी डिस्कस्ड यस्टरडे. आप जिसको 100 बोल करके कस्टमर को दोगे वो एक्चुअली वुड बी लेस देन 100. सो यू आर ओवर चार्जिंग द कस्टमर. फेयर थॉट?
So, sir, in this case, if bias is 0, then we can say it is accurate, otherwise it is not accurate.
अब आपने बायस का एक टारगेट बना लिया. सो इवन इफ इट इज नॉट 0
Okay.
एंड यू आर सेइंग दैट पेप्सी के केस में देयर इज लॉट ऑफ अदर प्लेज आल्सो, प्रेशर और टेम्परेचर का भी प्ले होगा. तो आपने कहा प्लस माइनस 1 बायस मुझे चलेगा,
Okay.
या प्लस माइनस 0.05 मुझे चलेगा. सो एक आपने एक्सेप्टेबल टॉलरेंस, एक्सेप्टेबल बायस का डेफिनेशन बना लिया.
Okay.
उसके अंदर में है तो हम कह रहे हैं माय इक्विपमेंट इज एक्यूरेट.
Okay.
नहीं तो बेस्ट केस वुड बी दैट जीरो बायस विल बी व्हाट वी वुड कॉल समथिंग एज एक्यूरेट.
Okay.
सो अगर आपने ध्यान से सोचा हो तो प्रिसिशन वाज अबाउट स्टैंडर्ड डिविएशन, एक्यूरेसी इज अबाउट मीन. सो मेरा एक मेजर इज मेजरिंग द वेरिएशन इन द प्रोसेस, एक मेजर इज मेजरिंग द सेंट्रल टेंडेंसी ऑफ द प्रोसेस. All of us?
Yes, sir.
Yes, sir.
Yes, sir. I have one question, but maybe this is not the right time. Maybe I'll ask after the.
Please. पूछो.
Sir, what happens? What happened actually in our process? When we were getting the data for one particular metrics, there was some kind of discrepancies. The customer was adding one particular attribute which was not even applicable to measure the performance of this particular metric. So when we told them that okay, this particular metric or this particular code shouldn't be included in our performance because that is actually deviating our or creating an issue in our target achieving our goal, so they removed it. The moment they removed, there was a lot of positivity in our performance. So because of that, if the project gets ended or the project is getting towards positive side, so we should, as a project manager, what should we do if we find the problem at the measurement time as well, or the only?
I will say that this should have been clarified at the data collection plan stage. What should be included, what should not be included. I'll give you another example. I personally know of a business process challenge about 4-5 years with one of the largest BPOs here. उनके क्वालिटी के कैलकुलेशन में जो टूल इस्तेमाल हो रहा था, उस टूल ने डिनोमिनेटर में नॉट एप्लीकेबल वाला कॉलम ही हटा दिया था एक्सीडेंटली. इट वाजंट इंटेंशनल. So there was a lot of variability between what the QCs of the team were reporting as the quality score and what finally the customer, the client, was reporting as the QC report. तो आपको तो ये verify करना ही पड़ेगा. And as part of your data collection plan, you should be able to clearly articulate this.
Okay.
So let's say there was a particular part number 1, measured by a person who is a QC. So I'm calling him QC number 1, and he mentioned to us that this particular part is a 10 gram in weight. Fair? Then I also have a part number 2, which was measured by the same guy, and he had told us that it was 12 grams. I have a part number 3, which was done by the same guy, and he's mentioned to us that this is also 14 grams. So when you set out to do measurement system analysis, कुछ भी हो, continuous data हो, discrete data हो, आपको करना क्या है? आपको करना है repeatability, आपको करना है reproducibility. Repeatability would mean part number 1 जो QC1 ने किया है, I will need to get it done by the same QC a few times. So now my part number 1, which was measured by my QC number 1, I have gotten the QC to do it 3 more times. Fair?
Yep.
Similarly, for part number 2, I will get the QC to do it as many times as I had asked him to do the part number 1. So part number 1 का मेरे पास 4 डेटा पॉइंट है. So मेरे पास part number 2 का भी 4 डेटा पॉइंट होना चाहिए. Part number 3, so variation observed between part number 1, part number 1, part number 1 and part number 1 is repeatability. Variation observed in part number 2, part number 2, part number 2 and part number 2 is repeatability. Variation observed in part number 3 and the subsequent measurements of part number 3 is what is repeatability. Correct, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
तो जब कभी भी आप मेजरमेंट सिस्टम एनालिसिस करने जा रहे हो, यू आर इसेंशियली लुकिंग एट डूइंग रिपीटेबिलिटी एंड रिप्रोड्यूसिबिलिटी. अब तो हमने पार्ट नंबर 1 करवा लिया QC1 से, रिपीटेबल एक्सरसाइजेस भी करवा लिए, बट आई ऑल्सो नीड टू वेरीफाई माई ऑपरेटर, इसलिए मैंने अब सेम पार्ट QC2 से भी करवा लिया. And every experiment in the world would work the best if the model is balanced. मतलब जितनी बार सब्जेक्ट इंटरेस्ट 1 ने किया है, उतना ही बार सब्जेक्ट इंटरेस्ट 2 से भी करवाऊं. सो पिछली बार हमने देखा कि पार्ट नंबर 1 हैज बीन मेजर्ड बाय QC1 4 टाइम्स, इसीलिए मुझे पार्ट नंबर 1 QC2 से 4 टाइम्स करना चाहिए. गेज R&R में ये मैंडेटरी होगा, बाकी में ये एडवाइजेबल होगा. Similarly, your part number 2, which was earlier measured by QC1, I will now get it measured by QC2. Part number 3, which was measured by QC1, will now be measured by QC2. So the same part which was measured by QC1 is now being measured by QC2. That is what we are referring to as reproducibility.
So, sir, here we can compare two individual set of data, or we can compare same set of data.
Please stop talking like a commoner. Can you be a little more specific with your question?
Yes, here we have compared data of QC1 and QC2 with same data points.
QC1 has measured 3 different parts.
Yes, sir.
Which part would you want to compare against? So you will have to decide कि QC1 ने part number 1 भी किया है, तो मैं part number 1 को QC1 ने जो किया था उतने ही टाइम में QC2 से भी करवा दूं. पार्ट नंबर 2 को भी जितनी बार QC1 ने किया था उतनी बार QC2 से करा दूं.
Okay.
Everyone, are we together so far?
Yes, sir.
Yes, sir.
Yes, sir.
When you run the Gage R&R test, when you are running the Gage R&R ANOVA, you must realize that वो आपसे 3 चीजें मांग रहा है. It is saying part number, operator and measurement data. Measurement data is very simple. Measurement data, आपके पास हैंडलिंग टाइम का डेटा पड़ा है, आपके पास साइकिल टाइम का डेटा पड़ा है, आपके पास क्वांटिटी डायमेंशन, जो जिस भी डेटा को आपको MSA के थ्रू करना है वो डेटा आप चूज कर लेते हो. ऑपरेटर इज द मेजरमेंट मेथड दैट इज बीइंग यूज्ड. इंसान होगा, टेक्नोलॉजी होगी, जो भी होगा वो आप डाल दोगे. One very important thing to understand is the part number. Part number is an unique entity जिसके basis पे वो repeatability, reproducibility verify करेगा. So Gage R&R will need a unique identifier. So let's say we are trying to do Gage R&R for average handling time. मेरे पास hundreds of calls है, तो उन कॉल का कोई ना कोई यूनिक आइडेंटिटी मुझे बनाना पड़ेगा. I will have to call them serial number 1 or call number 1 or call number 1341. उसी 1341 के अगेंस्ट में वो रिपीटेबिलिटी करेगा, उसी यूनिक नंबर के अगेंस्ट में वो रिप्रोड्यूसिबिलिटी करेगा. इन आवर केस वी हैव कोटेड देम एज पार्ट नंबर 1, पार्ट नंबर 2, पार्ट नंबर 3. एवरीवन?
Yes, sir.
Yes, sir. Line, sir.
Yes, sir. Yes, sir.
I will explain why I'm doing what I'm doing right now. When you conduct the Gage R&R ANOVA test, it starts with giving you a graph. Because we haven't added any variation in the data, this is the best case scenario. This graph that you are getting right now on the system is the best case scenario. कभी भी Gage R&R पढ़ने के लिए start with the graph on the extreme left corner. टॉप पे जो ग्राफ आ रहा है, start with comparing part to part against the Gage R&R. Prima facie, part to part should be much larger than Gage R&R. If you see that evident in your graph, only then should you move ahead. Part to part should always be greater than Gage R&R.
So what is the meaning of this, sir? Meaning of part to part is greater than Gage R&R. Which is higher. Part to part is higher.
Part to part essentially is the process variation. तो आप समझो कि अगर आपके पास डेटा है तो डेटा में कुछ inherent amount of variation होगा. Like in my case, I have picked up 3 parts. एक part 10 grams का है, दूसरा part 12 grams का है, third part 14 grams का है. There is bound to be variation क्योंकि मैंने 3 अलग distinct parts लिए हैं. That is the true variation in the process. Look at a call center environment. When you are doing a particular transaction, आपकी organization में, आपके business में बहुत सारे work threads handle होते हैं. Let's say there are 10 types of work threads that are happening. There are 10 different things that people do. Are we sure that every work item that is being handled in a BPO will always take the same amount of time? No. There may be some variation. कोई काम मैंने 1 मिनट में कर लिया, हो सकता है किसी को 1.02 seconds लगा हो, 1.02 minutes लगा हो, किसी को वही काम करने में 1.15 minutes लगा हो. So there is some inherent amount of variation present in the process data. वो process का variation है.
So, sir, can we say that part to part means number of data points in the data And Gage R&R is our operator and our equipment variation.
गेज आरएनआर को तो सीधा मेजरमेंट एरर बोल दो.
Okay. And part to part is our data points, all the data points which we are measuring.
No, वेरिएशन इन द डेटा.
Variation in the
आपके पास
between the data points.
हाँ,
Okay.
करेक्ट.
Got it.
ट्रू
Got it.
वेरिएशन.
Got it. Got it. Got it.
Up, if you see, they have added two more things saying repeat, reprod. All you guys can see this.
Yes.
Yes, sir.
So
Yes, sir.
अगर यहाँ पे कुछ वैल्यू होती तो वो आपको क्लियरली बता देता कि गेज आरएनआर मतलब मेजरमेंट एरर का कारण क्या है. इज इट बिकॉज ऑफ रिपीटेबिलिटी और इज इट बिकॉज ऑफ रिप्रोड्यूसिबिलिटी. Let me change the data. Let me add some variation in the data.
Sir, one clarification. Just wanted to be sure because I've read somewhere, I don't know where, that ANOVA is mostly used in the manufacturing plant, not in the service industry. Is it true?
No, it's not.
This is absolutely ridiculous. It is not only incorrect, it is ridiculous to say that way. Because एक बात समझो, these are tools cannot be restricted to manufacturing or बीपीओ में ना बहुत जगह तुमको ये सुनने को मिलेगा डीओई बीपीओ के लिए नहीं होता है. क्यों भैया? एक्सपेरिमेंट्स क्यों नहीं हो सकते हैं बीपीओ में? बिकॉज समवन इज नॉट केपेबल. उसने एक नया चुटकुला इजाद कर दिया दैट बीपीओ में ये नहीं होगा.
Some business excellence manager told me this.
God bless him. God bless his soul. and God bless the company that has hired him. So I've changed the data a little bit. And now if you see, I have some things visible in my Gage R&R wala ilaka. Also in repeatability and reproducibility. So if you compare the bars, it is clearly saying that repeatability मतलब equipment variation कम है, reproducibility मतलब operator variation ज़्यादा है. You should take a deep dive and look at what is the variation that is being observed and try and fix it. Walk up to the SMA. देखो what went wrong. Draw line graphs and bar charts and box plots to see what has happened and try and fix it. When you are assessing the Gage R&R, you are essentially looking for three things. एक चीज जो आप देखते हो वो है number of distinct categories. All of us can see this?
Yes.
Yes, sir.
Yeah.
Number of distinct categories must always be 4 or more. दूसरा, Gage R&R as a percentage of contribution, currently it is 28.62. Gage R&R as a percentage of total contribution must be much less than part to part. अभी है.
So can you repeat it? Should be less than how much value?
I have a question, Mita. Mistake ज्यादा होना चाहिए कि variation ज्यादा होना चाहिए? Mistake तो बिल्कुल acceptable नहीं होना चाहिए. Mistake should be as close as possible to zero. No?
Yes, sir.
बस यही है. Total Gage R&R, compare it with part to part.
Okay, sir.
Total Gage R&R must be as small as possible to the part to part.
Got it, sir.
तीसरा, if you have specified some tolerance, which I had specified, Gage R&R as a percentage of tolerance, अगर 10% से कम है, let me write down the rule here. If it is between 10 and 30, chalega with caution. If it is greater than 30, reject. Here if you see, my Gage R&R का tolerance is 53.5%. थर्टी से ऊपर है, करेक्ट एवरीवन?
Yes.
Yes, sir.
Yep.
टोटल वेरिएशन उसके राइट वाले कॉलम में देखो, टोटल वेरिएशन इज 1724, आउट ऑफ विच 922 comes from the Gage R&R. So this is about 53%. हमारा रूल ये कह रहा है 30% से कम होना चाहिए. Hence, we will outrightly reject the measurement system. Number of distinct category भी फेल कर गया. Number of distinct categories 4 या 4 से ज्यादा होना चाहिए. In this case it is 2. यहाँ पे मेरा परसेंटेज टॉलरेंस 30 से कम होना चाहिए. It is 53. और ऊपर भी percentage contribution is still very high. It is at 28 and I am not okay with 28. Everyone?
Yes, sir.
उसके ऊपर
Yes, sir.
Yes, sir. Yes.
what was the path? Stats, quality tool, gauge study, and depending on what is your sample, destructive अगर sample है तो nested design इस्तेमाल करेंगे, reusable sample है तो cross design यूज करेंगे. So if you have a sample that you can reuse for measurement purposes, then that is called reusable sample. मतलब अब मेरे पास let's say I have a phone जिसका weight is a deliverable, and I can keep taking the weight of that tool as many times as I want. On the other hand, if there is I want to find out at what temperature does a particular vase break, what is the breakage temperature of a vase. So how will I capture data? I will heat it till to the point that the vase has broken. Destructive samples. Everyone?
So one more time, please. This one.
अगर sample मेरा reusable है, I am taking weight of something, I am taking the length of something, that is reusable sample. अब आप सोचो कि मैं जानना चाहता हूं कि डिस्प्रिन आप पर कितने देर में असर करती है. I gave you discipline, you consumed it, and then I measured how much time did it take to help you. Now that discipline is gone. वो तो आपने कंज्यूम कर लिया, तो मेरे पास जो सैंपल है वो तो रीयूजेबल नहीं रहा. दैट इज डिस्ट्रक्टिव सैंपल.
Okay. So,
Everyone?
yes. So for destructive, we use nested. Okay.
याद रखिएगा, न्यू दिल्ली ND नेस्टेड डिजाइन, तो हमेशा डिस्ट्रक्टिव सैंपल होगा. और गेज R&R रनोवा में 3 चीजें जो हम चेक करते हैं. एक हम चेक करते हैं गेज R&R में नंबर ऑफ डिस्टिंक्ट कैटेगरीज. Number of distinct categories must always be 4 or more. दूसरा चीज जो हम चेक करते हैं, Gage R&R is a percentage of tolerance. Gage R&R should be as small as possible, especially in comparison to part. And finally, Gage R&R as a percentage of tolerance must be less than 30%. Up to 10% is considered to be good. Between 10 and 30, you should accept it with caution. Greater than 30, you should reject it. Everyone?
Yes, sir.